My name's Colin Stevenson with Pivotal. I work on our partner team. We work closely with our friends at Microsoft, Google, all kinds of partners. Prasad here is on the team as well. And here today we're talking about how to quickly build Spring Boot apps consuming public cloud services. So quick question, who uses Azure or GCP or AWS services with their Spring applications today? Great. So we actually did this talk back in June and at the CF Summit. Things have changed a bit, so we wanted to give an update and a refresh. Kind of assume not everyone would have been at that session anyway. So going over some of these, at the time, we actually built out a number of Spring Boot starters to work with Azure services and GCP services based on the service brokers that were available for Pivotal Cloud Foundry. And so since then, we've actually worked closely with the Microsoft and the Google teams directly as opposed to just building our own. And we want to give a big thank you to those teams. So Microsoft, Google both have dedicated teams working on Java. You've probably met some of them at their booth. They're also teams that have built out open source service brokers to run on Pivotal Cloud Foundry. And so what we found when we originally created these starters and started working with them was a number of customers are running Spring Boot applications on PCF. They're using these services, but they didn't have the starters available to them to help make this a little easier. So we're going to talk a bit about those. You can see here, if you are using Pivotal Cloud Foundry, there's these tiles available. You can run these on any PCF that you're deploying to, as long as you have connectivity to those cloud service providers. In terms of what's actually in the box, right? So back in June, there was a smaller list of these services. And since then, we've seen adoption and use cases in our customer base where, for Azure, for example, they released their MySQL and their Postgres service as generally available. They updated their document DB database, now called Cosmos DB, that has a lot more capabilities. It's got Mongo API interface. So a lot of these have these open standard interfaces that you can use. And customers are trying out many different ways to approach how they deploy these Spring Boot starters, Spring Boot apps using starters with these services. So one of the questions we typically get is, well, what about vendor lock-in, right? If I'm using these services, am I going to be stuck? How hard is it to switch? Some of the benefits that we're seeing from these cloud providers in building service brokers, one, they're moving over to use the Open Service Broker API. So across all three of them, they're rewriting or modifying their brokers to support this open standard. The benefit there is it lets you deploy these to both Cloud Foundry, or if you've heard the announcements around Pivotal Container Service, you can use the Kubernetes-based service catalog to call these services as well. So if you happen to be deploying Spring Boot apps on Cloud Foundry or find yourself with the need to deploy them to a Kubernetes-based environment, these service brokers will still work. This just reduces the friction in terms of being able to deploy these applications in a variety of modes and kind of reduces the risk of lock-in. There's also a lot of benefits to these managed cloud services. So being able to, as a developer, quickly get access to a service and then write your Spring Boot app to do that. So that's where the starters come into play. Who's used VCAP services before or had to parse these? Anyone? Is anyone doing them manually today? So if you're deploying a Spring Boot app on Cloud Foundry, you'll see that there's this VCAP service environment variable. You have to parse this. So once you have these, how do we do this, right? This is where the starters come into play. This is the hard way. It's not terribly hard, but it's more than you probably want to do, especially if you have a larger development team that's trying to use these different services. You have to read in that environment endpoint. You have to figure out what JSON libraries that you want to bring in as a dependency that you're now going to use to parse that payload. You have to figure out what, from the cloud provider side, what are the libraries that they're providing that you want to import. So if we can shortcut a lot of that, hopefully as a developer you can iterate much faster. So that's where Spring Boot comes to the rescue, right? So who's been to start.spring.io? Hopefully everyone. Today, if you go there, you can actually start to type in and get an autocomplete on Azure. So again, working with the Microsoft team, we got that structure in place for these services. There's a number of them that work with Cloud Foundry. Some of them are Azure specific. And over time, we'll see the combination of those two coming together. But today, you can see there's a general Azure support group. There's Active Directory, Key Vault, and storage. GCP has starters as well. Those will be coming soon. They've submitted the PR. There's some review involved, but those will be coming, and you'll be able to get access to those there as well. And obviously, for AWS, there's already the Spring Cloud AWS capability. And so with that, I'll hand it over to my trusty colleague, Prasad.
All right, thank you, Colin. So it's demo time. We barely have any time to waste here. So as Colin mentioned, we gave this talk a few months ago at CF Summit. At that time, we did a slightly different demo. What we are going to do this time around is that take a slightly different spin. We are going to do a live coding session. Our talk says that quickly build these applications. So we'll see how quickly we can actually build them, right? So what exactly this demo is going to do? So this is just a simple pictorial representation of what this demo is about. So there is a simple demo application. It will be a web app running inside Pivotal Cloud Foundry, of course. And it's a web app that will expose an endpoint. And a user will be able to upload an image or any file for that matter on this endpoint. And this app will go ahead and talk to Azure Storage Service as well as Google Cloud Storage Service. And it will upload that image in both these services, okay? So let's get started here. So I'm going to exit out of this presentation mode and go inside my web browser for a second here. And before I actually get started with running this demo, I just wanted to quickly show this Cloud Foundry environment where this demo is going to run, right? So this is the Pivotal Cloud Foundry Ops Manager. And it's running on, this PCF instance is running on VMware vSphere. And these are the two tiles, the Microsoft Azure Service Broker and the Google Cloud Service Broker. These are the ones that we need to pay attention to because that's what we are going to use, right? So when we have these service brokers, as Colin explained earlier, what happens, what we are looking at right now is the Cloud Foundry Applications Manager. And this shows a list of both Azure as well as Google Cloud services which become available in the Cloud Foundry marketplace by virtue of those two service brokers that we saw on the Ops Manager. So there are about 9 Azure services and about 8 or 9 of GCP services also, right? So before I begin the live coding, what I want to do is I'm going to use a couple of Cloud Foundry commands to go ahead and spin up a couple of services in Azure and in Google, right? So I'm going to go ahead and go into my terminal. And let me magnify this a little bit. So this command that I'm running here, what it does is it's a Cloud Foundry create service command. It is creating a service instance for Azure storage. And so this service instance got created. And let me go ahead and run another command here. This is for okay, let's just magnify this. All right, so this is the other command, and this is going to go ahead and create a service instance inside my Google storage. So what happened here is if I go into my Azure console, when I spun up the Azure service, it went ahead and created an Azure storage account here called S1P storage. I just refreshed the screen and it popped up, right? And similarly, if I go into my Google Cloud console, and if I refresh this page, what it did is it created a storage bucket by the name S1P images over here, okay? So some subtle differences in how both Azure and Google Cloud handle their storage system. So, as you saw, so I created a storage account in Azure, and I created a storage bucket in Google Cloud. So these are the containers where I'm going to be uploading that image eventually in my application. All right, so now I have these service instances spun up. So if I go back into my console, and if I run a CF services command, and if I magnify this a little bit, as you see that I have a couple of service instances that I just created by those two commands, right? All right, so now let's go ahead and build our application. And So now I have to bootstrap a Spring Boot app, right? So where do I go? What do I do? Start.spring.io, yes. So if you are a Java developer, you gotta have this link bookmarked on your web browser, right? So I'm gonna go ahead and spin up a project here. So I'm gonna name my group ID as io.pivotal. I'm gonna name my application as SpringOne. And now I have to choose my dependencies. I know this is a web app, so I'm gonna type in web, and I select web. And then I know that my app is going to depend on the Azure and GCP starters. So I type in Azure, and Colin talked about this. How cool is that? We can select the Azure starter straight up from the Spring initializer. So I chose Azure support, and because this is going to use the storage service, I add Azure storage. And the GCP starters at this point are not there here, but they will be available pretty soon. So we will add the GCP dependencies manually in my project. I go ahead and click on Generate Project. I have the project bootstrap. I go back into my terminal, and I'm going to move that zip file into my working directory. And I will unzip it here. And just remove the zip file altogether, and then cd into All right, so I am inside my project directory now. Let me increase the font a little bit so you can see it. Great. So now this project is ready to be imported inside my IDE. So I come here in my Spring Tool Suites, and I go ahead and import existing Maven projects, browse, and choose SpringOne, open, and finish. So I have my project inside my IDE now, right? Let's go ahead and before I do any coding, let's open the POM file for this and take a quick look at it and try to understand what's going on here. So this is the XML view of the POM. Let me magnify it again a little bit. And if you look at the dependencies, you see that there are two Microsoft Azure dependencies. So these got inside the POM automatically because of those starters that we chose from Spring Initializer. And as I mentioned, I will need to manually add the GCP dependency, so I'm going to just copy and paste it from another file. Copying and pasting only because I don't want to make any typo errors here. So I added the Google Cloud Starter dependencies also. And if you notice, it says io.pivotal.gcp.sb, and that's because this is a copy of the starters that we wrote. Pretty soon, the Google starters that are officially published by the Google team that will be available. So I think the group ID and artifact ID for that will be different. So we have the project dependencies all taken care of now, right? Well, another quick thing that I wanted to do is I'll go ahead and turn off my unit test case just because in the interest of time, I don't want my Maven builds to complain about any failing tests. So that's not a good habit, okay? So make sure you do not turn off your unit test when you do your coding. So, all right, so I'm gonna go back into the terminal, and I'm inside my SpringOne directory already. So I think I can go ahead and start coding my app now. So I will go ahead and open up and start building my REST controller. So I open the SpringOne application class, which was auto-generated for me. And I'm gonna go ahead and make this my REST controller. So, all right, so this becomes my REST controller. Now the next thing I'm gonna do is I'm gonna declare a couple of variables here. And just in the interest of time, I'm gonna copy and paste these two lines. All right, and let's try to understand what I did here, okay? So these two variables I just defined, cloud storage account, it's part of the Microsoft class library for accessing the Azure cloud services, and similarly the other one is from the Google class library. So if you are manually writing this code, then you would have to basically use this class library and you will have to instantiate these beans and then make API calls to access those cloud services, right? But what's going to happen because of starters here is, as you can see the auto-wired annotation, these beans will automatically get instantiated and will be injected inside this class. So you do not have to write any code to instantiate these beans. Now let's take the next and final step, and that is to write this implement this method, which will define the endpoint. So I'm going to, again, copy and paste this. And again, this is just a few lines of code here, and don't want to make any typo errors. That's the only reason I'm copying and pasting this. So let's try to understand this method now, OK? So it's a method called upload, and it takes, as you say, it has this endpoint upload file. And let me magnify this a little bit so you guys can see it better. Right, and it takes 3 parameters, right? The first parameter is called file, and it is of the type multi-part file. That's the file the user will be uploading into this endpoint, correct? And then there are 2 other parameters, which are like string parameters, which the first one is called the GCP bucket name. So that's the name of the Google Cloud Storage bucket where I'll be uploading the file. And then the other one is the equivalent in Azure, is the Azure container name. So we'll be passing those in as parameters, and the code will actually take the file that is streaming in and just upload it to these 2 final destinations. So if you take a look at this code, the first couple of lines is basically uploading it to the Google storage bucket. It makes use of the storage bean, and what it will do is that based on the GCP bucket name, it will get an instance of that bucket and just upload that file there. And similarly, the next few lines here, these are part of the Microsoft class library to do the exact equivalent with the Azure container, right? So what it will do is that it will create the Azure container by that name if it does not exist, and then it will go ahead and upload it. So we have the app ready and good to go. So what I'm going to do is I'm going to go back into my terminal, and let's go ahead and build this app. And it should build pretty soon, so cool. So the build is successful, and now I'm ready to push this application. I just need to do one more quick thing here, and that is to build my Cloud Foundry manifest since I'm pushing this to PCF. So I have a manifest file already that I have built, which I'm going to copy here. So let's do a cat on that manifest. So very simple manifest file. All it does is basically gives a name to my application, SpringOne, and it specifies the path to the build file, which is the jar file, right? So let's go ahead and push this to Cloud Foundry. All right, so the application is being pushed. Oops, let me just cancel this. I wanted to push this app with a no start flag, and I'll tell you why I'm doing this. So the reason I'm trying to push this app without starting it is because I need my application to bind to those service instances that I created earlier, okay? So it is not bound yet, so I'm just pushing it. So it's there now in Cloud Foundry. If I do a cf apps command, as you see that I have my app, but it is in a stopped state. And if I do my cf services as I did earlier, you can see those service instances, and they are not bound to any apps. So the next thing I need to do is do the binding together. So I'm going to run another simple Cloud Foundry command to do the binding of these service instances. And I'm going to run both these commands simultaneously. I mean, one after the other, but together. So the binding should be done in a second here, and we are good to go. So if I run the CF services again now, as you can see, now the SpringOne app is bound to both of my service instances. So now I can go ahead and start the application. So I do a CF start SpringOne. And this is where Cloud Foundry does its magic. It will take all my application binaries, and they will be, it will try to detect the appropriate Java runtime, the build pack for my application since it's a Java app. And then it will, containerize the application. It will spin up the container. It will start the application inside that container. It will also create a routing URL for my application so that it is accessible. And as I was describing that, boom, we are ready here. So as you see, my application's route is this, and it is ready to be accessed. So I'm going to use Postman to run and test this app. So I go ahead and paste this link, and my endpoint is /upload file. This will be a post. I go inside the body. I have to define 3 parameters, right? The first one, as I showed you earlier, was called file. and it was not a text. It is actually a actual file that I can choose. So I'm going to upload this file of the beautiful Golden Gate Bridge to this URL. And then I have to define another couple of parameters here. The second was GCP bucket name. And I think I created a bucket named S1P-images. And the third parameter was the Azure container name. And let's call it, let's say, images. The one thing that I forgot to show earlier, and I'll do that quickly before I actually run this app, is earlier right at the beginning when I spun up those services in Azure. So, I think I did show this. So this, yep, the bucket and the storage container that was created. So let's go back here to Postman, and I'm going to go ahead and hit send, and let's see what happens. And I get a true back, which means it worked in first shot. That's a great thing. So I'm back in my Azure console now, and if I go ahead and click on the storage account name inside this, if I click on blobs, and I'll need to refresh this page, and I see this container called images that got created, and inside this container, I have my Golden Gate Bridge image. And the same thing here with the Google Cloud Console. If I refresh this page, and this S1P images bucket that we created earlier, I'm going to click on this, and I have the Golden Gate Bridge image over here also. How easy was that? So, I mean, it barely took any time to build this entire app. And I remember, I did not just build the app, I also spun up those services in these clouds, right? So if I go back into the presentation mode, let's try to summarize what we just accomplished. Colin showed this slide earlier. So the most important thing to learn from this talk is that, all these steps, they were entirely eliminated from these, when you're using the starters, okay? So these steps definitely take some time. There's a lot of boilerplate code involved in this, and the starters actually eliminated all of this. And the very important thing here is it's not just the speed, that these starters give you. It's also, very importantly, we need to understand it's about the model and the pattern that is promoted by the Spring experts. So when you use the starters, you are adopting to the right standards that are highly, highly recommended. And another important point not to forget here is that let's imagine that you were using the starters, but you were deploying your app not to Cloud Foundry, then you would be spending quite a bit of time in spinning up your Azure and Google Cloud services, copying all the service credentials, adding them to your application's properties file, and absorbing them into your application. All that time was also saved. You did not have to do any of that, and that was because of Cloud Foundry. So it's the starters and Cloud Foundry together, as Onsi very well described in his keynote last year. They are independently very awesome, but together they are like a delicious peanut butter jelly sandwich, right? So use Cloud Foundry and use the starters. Finally, key takeaways. I think if you are a Java developer, I cannot think of any reason why you would not want to use Spring Boot. So yes, use Spring Boot. The service brokers are constantly evolving, so use them. There will be more and more services that will be added to the GCP and Azure and even the AWS service brokers as we move on. And lastly, if you are writing Cloud Foundry applications and you're using these services, then yeah, absolutely, highly, highly recommended that you use these starters. Finally, some important resources here that you could take a look at. And yeah, I think that's about it for the demo. I'm glad it worked. Any questions?
So,
yeah.
I think it was first.
Go ahead.
You mentioned that Cloud Foundry and Spring started together. You mentioned the portion about Cloud Foundry being able to set up Azure and Google. How did it do that? Maybe I didn't see that. Was that in some of your early scripts?
So yeah, right at the beginning, so the question is what role Cloud Foundry played into this that really helped speed things up, right? So right at the beginning, before I even started the coding, I actually ran a couple of Cloud Foundry commands that did create the services. So what happens is that the service brokers that we have installed, they provide this mechanism to go out and talk to these cloud services and spin up those service instances. So they get spun up, and then you have the credentials ready that you can actually provide to your application. And to provide those credentials, if you remember, like just before I ran my application, I ran the Cloud Foundry bind service command. That takes those credentials and injects them into the application's environment.
Yeah, if you just spun it up independently, the service in Azure, so you go to the portal, say, give me a blob storage, set it up that way, then you have to go in, you have to get a very long string, it's like a primary key with username, password, all that.
Correct.
Yeah,
Correct.
exactly. So there's like 3 key pieces of information that you would then copy paste into your application.properties file. You'd still have to, a Spring Boot starter could still parse those, which is nice, if it exists, right? But if it doesn't exist, then you're, back to coding the boilerplate to handle how you map those in. And then I think you also showed those beans that you had, they're auto-wired. So at startup, right, that's information's all pulled in, and the auto configuration that's applied through the starter as well. Yep.
Yep, go ahead.
What would you do to boot that up locally? Since you auto-wire those dependencies, they're getting injected only in the cloud, right? What would you do if you need to boot it up locally and see what's going on?
You'd still, so for those the question was how would you boot that up locally? The services would still have to exist in the cloud, so there's no local way to have Azure Blob Storage or GCP. So you have to have that connectivity. The Spring Boot app itself can run locally, assuming you have that information. So if it's not running on Cloud Foundry, you don't need to parse VCAP services, but those starters actually handle both cases. So if you're running it locally, it'll pull in from the application.properties file. So you would have to do that locally. It's the benefit of then pushing to CF and having the Java build pack handle all the mapping at that startup helps with that rapid iteration.
Yeah.
We able to create our own services, or do we have to only use vendor services? Say that I have our own storage for the enterprise, and we wanted all applications to be in that storage. So I wanted to create a service to make it available on Cloud Foundry.
Mm-hmm.
Is that possible, or what would it take?
Yeah.
Yeah, so the question was, can you create your own service? So if you have your own enterprise storage and want to have that be brokered through Cloud Foundry, yes. So the Service Broker API or the Open Service Broker API is a series of interfaces: create service, delete, bind, unbind. You can create a catalog, so however you want to define what those instances would look like. There would be a catalog that would be surfaced in Cloud Foundry based on that API. And so when a user issues that create service command, it would then provision those resources and provide the credentials when you bind the application to that instance. So you can write all of that yourself. There's actually a Spring Boot, it's a Spring Boot service broker. So it helps scaffold as a Spring Boot application. You just fill in the logic for what you want to happen as a part of that broker.
So the point to understand here is that you need the service broker to publish any of your services in the Cloud Foundry marketplace. For any of the popular services, service brokers already exist. If you have some custom services, you implement that service broker, register it with Cloud Foundry, and boom, your services are available in the marketplace.
Should it be registered with the public Cloud Foundry, or
No, the Cloud Foundry instance that you are using, in that instance, you will have to register it.
All right. Great. Well, thank you. Any more questions? We'll be outside. Thanks for attending today, and have a great rest of the conference.
Thank you.